Welcome to the public AI4EU Cafe in 2021. This is the first cafe this year, and we are having a real special guest. That's Fredrik Heintz. He's the coordinator of TAILOR. And TAILOR is basically an ICT-48 sister project, a European research project, and the talk will be on foundations for trustworthy AI, integrating learning, optimization, and reasoning. And who am I? I'm Carl McWilliams. I'm your moderator and organizer of the cafe. I'm partner in the European AI4EU project and also in the AI for Media project. And my company is funded basically as partner in those both projects. And so just for the cafe, as you always know, please take notice, this session will be recorded. No confidential information shall be shared in this cafe session. And in this cafe, each speaker expresses his or her personal opinion. It's not necessarily a project opinion or the official European Commission opinion or the AI4EU project opinion. So everybody's free in this cafe, also when you answer questions or if you give questions to the speaker. That means this is interactive. So if you have questions to the speaker, who will soon get his word, please write them down on the right side, interactive. So you have on the right side a panel, and you just, there's a text chat, and also for questions, just write it in. And I will read the questions to the speaker afterwards, after the presentation, and then we have a nice Q&A session. And so I hope all your questions will be answered. If not, maybe you can even ask them afterwards in an email, but it's up to you. So now we start. The show is starting. All the people are coming in. It's really impressive. Today we have more than 250 registrations. Already more than 100 are still entering in the cafe. It's getting full. So now to you, Fredrik. Hello, how are you?
Hello, I'm fine, thank you. How are you?
Great. Yeah, I'm so happy that you're here. Without you, this cafe would make no sense. So you are.
Thank you for organizing it and providing this opportunity to spread the word about what we're doing.
Yes, yes, that's most important, because it's great that we have a public who's interested in our work, and it gets more and more. We have also people from Canada and from India, but mainly, of course, Europe and from US. So it's spreading, and it's nice to speak about our work. I want to introduce you shortly, and then I give you the mic. Then it's your talk. So Fredrik Heintz is the Associate Professor of Computer Science at Linköping University in Sweden. He leads the Reasoning and Learning Group within the Division of Artificial Intelligence and Integrated Systems, which is called AIICS, in the Department of Computer Science. His research focus is artificial intelligence, especially autonomous systems, stream reasoning, and the intersection between knowledge representation and machine learning. He is the coordinator of the TAILOR ICT-48 network of AI research excellence centers and the director of the graduate school for Wallenberg AI and autonomous system and software program. Wallenberg AI autonomous system software program, and the president of the Swedish AI Society, and a member of the CLEAR extended course system, and a member of the EurAI board, and a researcher at the AI Sustainability Center, and a member of the European Commission high-level expert group on AI. Wow, that's a long list, and great. And Fredrik is also very active in education activities, both at the university level and in promoting AI, computer science, and computational thinking in primary, secondary, and professional education. He's fellow of the Royal Swedish Academy of Engineering Science, IBA. So, as I say, impressive, and thank you that you are here, taking your time to give us an insight. And I will make you now the moderator. So it's up to you to speak, to introduce yourself, to show your slides as you like. Great, I see it.
Thank you very much for the introduction. So what I want to do here today is to give an overview of this topic of trustworthy AI, and especially this ICT-48 project that I'm coordinating, the TAILOR project, which is all about developing the scientific foundations for trustworthy AI. So the outline of my presentation here today is that we'll give a short background. I'm sure you're quite familiar with that. Then I will be spending most of the time presenting the project and the things that we are doing within this network. And then at the end, there will be opportunity for questions. So of course, everyone is well familiar with the work on AI. I mean, we have seen really impressive applications the last 10, 15 years. Everything from, I mean, self-driving cars, even though there is some question about how quick they would come, but the superhuman performance in all kinds of games like chess, Go, poker, Jeopardy, StarCraft, Dota, so on and so forth. And of course also robots that may look a little bit scary. And behind all of these very impressive applications, we have this concept of artificial intelligence. So an image that I like to talk about is this. So this is KG, 19 years old after or during the game against Google DeepMind's AlphaGo a number of years back now. And he looks a little bit sad. And in an interview after the game, he said that he felt that he would never, ever have a chance against the computer because the computer was playing like a god. And of course, this is a very interesting statement, especially from someone that young that should still have a lot of potential to develop further. But what I'm actually most interesting to me, and what was most interesting in these games, were really to look at the human expert commentators and how they were commentating the games. Because of course the computer was learning from to play based on human games, but it was also very obvious that the computer were able to come up with new ways of playing this game that people hadn't done before. And I do think that is really well shown by looking at these expert commentators, because there were several times during these games where the expert commentator said something along the lines of, haha, the computer made a mistake. A human would never play like that. And of course, we all know what happened. The computer won the game. So it was clearly that this was a, objectively good move. But still, we, or humans, thought that this was a bad move. And I think this is really interesting. So, this relates to this concept of meaningful human control. So how should we as humans judge or determine whether the recommendations or actual actions by these systems are good or bad? Because normally what we do is actually compare to whether it's like we do it or not. So it's similar to a human move, yes or no, rather than saying, is this a good or a bad move? And I think this is really one of these interesting questions. How do we maintain this meaningful human control over systems that may be doing things in a completely different way than we are doing it? So that's a very interesting question that is raised by this games. I also think it's interesting to be, I mean, to me, it's a clear sign that computers are creative in the sense that they can actually come up with new ways of playing this game that we have not found out before, and it was really progressing the way you play this game. So I think that's some interesting things. A second example that I do think is very useful in this particular case is the following. So these looks like images of people just like you and me. But the interesting thing is that these people do not exist, but rather these are computer-generated images. So the computer has taken a large set of images of real people and then learned a model for how human faces look like, and then used this to generate very realistic looking faces. And of course, again, this raises a number of very interesting questions. So for example, we have seen a lot of these deep fakes. So I mean, you take a movie, or rather you take maybe some I mean, you can put the face of a person in a situation where that person does not want to be, or you can generate fake content, for example, having a well-known character saying something that is not true. So today it's actually possible to generate text, images, videos, sound, and so on, which is more or less indistinguishable from the real thing. And how do we then as individuals and as a society deal with this potentially disturbing and disrupting incorrect information or fake information? At the same time, so I mean, we really need to be more critical and better at judging whether what we see is actually true or not. But it's also very interesting to ask, what is a real image? I mean, I would expect that if you take a magazine, almost every image in that magazine will be photoshopped. So it will be, every image will be manipulated. So why don't we, or I mean, I know there are cases where people say, oh, this is not true, and so on. But there's another aspect of this. So again, these technologies can in some sense be used both for good purposes and bad purposes. So we've seen this kind of spreading of fake news as one negative example. And a positive example could be that we have a lot of data that is sensitive. For example, it might be for privacy and personal integrity issues that we don't want to, or are not allowed to. So we don't want to share the data as it is. But instead, we can then use these type of techniques to train and learn models to generate synthetic data with the same properties as the real data. And of course, this could be very interesting, for example, in medical applications, where we often have this sensitive information, sensitive personal information. Personally, I've been involved in projects where a telecom provider has a lot of information about the location of people. So of course we don't, or the company don't want to share that, but they also want to provide services based on this position information. For example, if you're planning the city, you want to evaluate different actions taken by the municipality. For example, I don't know, there is some area of the city which is considered to be unsafe, and they install more lighting, or they make some changes, and then they want to verify or check, does this change the behavior of people? Do people feel more comfortable spending time in this area at night, and so on? And then by learning these models of how people normally move around, we can then generate synthetic individuals that behave like real individuals, and then you can verify, or at least evaluate these policies, for example. So I think that's a very interesting development, this synthetic data generation, and so on. So I mean, we were talking about AI. I mean, I'm sure you're all familiar with AI, but what I do think is interesting is that AI is one of these topics where there are many different definitions. And personally, I actually think it's a good thing that there are many different definitions, because each definition captures one aspect of AI. And I mean, what I usually say is that AI is all about understanding intelligence well enough in order to actually build systems that act in an intelligent manner. So you're able to build engineering solutions based on this concept of intelligence. And today, I mean, the main applications that we have seen making huge progress the last couple of years is everything related to perception. So computer vision related voice recognition. So you can actually use the voice to control the computer, which of course opens up a wide range of new applications. I mean, it might be people who are not able to type. I mean, it could be kids who haven't learned to type yet, or it could be other people for other reasons that cannot type, or you have people with working situations or situations where you cannot use your hands, such as, I don't know, a surgeon performing surgery or a truck driver driving their trucks, and then we don't want them to use their hands for other things, and then they can use the voice to control the computer systems. And related to this, of course, natural language processing. So here we're seeing huge progress in automated translation, for example, and automatically analyzing texts and so on and so forth. So we have seen a lot of progress in different applications. What I also think is important is to recognize that, I mean, taking chess as an example, I mean, the computer is clearly better than we are. I mean, we've seen the same with Go, of course, but if you combine humans and computers, then they're better than both the best humans and the best computers. So the point here is that it's not a question of either AI or humans, but it's really about AI and humans together. And we can see the same kind of effects if we compare to, for example, medical diagnosis, where the humans and the doctors, I'm sorry, the human doctors and the decision support systems make different types of errors. So if you combine these results, you get a better diagnosis. So I really think it's important here that it's about AI and humans together. But it's very important to keep in mind that it's a different skill to play chess with a computer compared to playing chess without a computer. So it's really about how can we solve problems together with computers, or using computers as very powerful tools. And that's why I've been so engaged in educational activities, especially around this concept of computational thinking, because to me, computational thinking really captures this, how, I mean, the kind of thinking processes involved in solving problems where you use computers as a tool in solving these. So that's very important. Another consequence of this is that it's not only about, I mean, buying equipment or investing in software tools. It's also very much about educating the staff, the people, and to adapt your workflow in order to leverage these tools and so on. And I mean, the example I usually use here is a study done in Swedish schools where they made a comparison between classrooms where they just introduced computers, they didn't do anything else, and there the kids got worse results compared to the control group where they just did their normal teaching. But then in the group where they introduced computers into the classroom and the teachers adapted the pedagogy to really leverage these tools, then of course the results became much better. And that, I think, is the key here. And then of course, I mean, I mentioned some of the issues, but there are a number of other issues that are also kind of well known. For example, that small changes to the input for this machine learned system can generate large changes in the output. So of course, that's a major issue. Another issue in these data-driven approaches is the bias. So there is a lot of different types of bias in the data. It could, for example, be that data is not representative. I think this in some sense is the easy case, because then it's more about collecting more data, and sooner or later you will have a much more representative data that hopefully will also generate better outcomes. But what's interesting is, of course, the cases where the world is not the way we want it. So, for example, there is a gender bias in the salaries, so that men and women tend to have different salaries even for very similar jobs. And there is also kind of a gender bias in what type of jobs we have. And now when you want to build your system to do match people to jobs, if you train it just on the kind of available data from the labor market, there's a big risk that your end solution will also be biased in the same way. But here, of course, the challenge is that someone needs to make a normative statement and say, we don't want the world to be like this, but we want the world to be like this, and then to basically adapt and generate data that corresponds to the way you want the world to be. So that's of course a very different thing. So bias is a major and very interesting challenge. What we have also seen is that even these very, systems that appear to be very successful, people are starting to analyze the way that they work, and in some cases came to the conclusion that actually it looks like these systems are actually using quite simple heuristics. And if you add these questions where you basically add a negation to it, then suddenly they become the kind of quality, the accuracy of the systems drop dramatically. And one of the reasons in this particular case at least is that most of both the training and evaluation data is on positive cases and not that many on the negative cases. So it means that your system will get really high accuracy by basically focusing on the positive cases and not caring that much about the negative cases. And of course, this is also very much related to the fact that, in certain situations, say in medical situations, where you, where, for example, in kind of almost every case, it's a positive, or a negative, hopefully, and it's that there is no disease, but only in a very, very few cases there is a disease. And how to deal with this statistically, because statistically you always say, oh, there's not a problem. But what's of course important is that the few cases which really matter to do them right. So there are a lot of interesting challenges in both evaluating and in training these systems to make sure that they actually are right for the right reasons. And all of these kind of background taken together comes into play for this European approach to AI. And I really think it's really important and good that EU has been very, very clear with that. Yes, we want AI, but no, we don't want any AI. We want AI that's human-centric, meaning that AI is not a means, it's not an end of its own, it's not a goal in itself, but rather a mean to improve the situation for us as individuals, citizens, consumers, and so on and so forth. And secondly, that we don't want any AI, but we want trustworthy AI that we can really put our trust in. And in this high-level expert group that I've been part of, we then defined trustworthy AI to be AI that satisfies the applicable rules and regulations, so it's lawful in that sense. And I mean, this is of course very good and very a desired property. At the same time, there are challenges also with this. For example, assuming that you're developing an autonomous car, and the autonomous car happened to end up in a situation where, for example, the car in front of it is slamming the brakes, and the self-driving car behind it may end up too close, and then it might violate the rule and turn driving over a solid line and kind of passing instead of colliding. But assuming now that they break the law and avoid this accident, how do you argue in retrospect that I needed to break the law in order to avoid this accident? So I do think there's a major aspect here about maybe it will be something safer for the company perspective to actually rather than breaking the law, still maintain this risk of having an accident. So I think there's interesting tensions here. The second aspect is that the system should satisfy a number of ethical principles. We formulated 4 of those. And then last but definitely not least is that these systems also have to be robust, meaning that good intentions are not enough, but you really have to have a safe and secure and really robust implementation of your system. And I really think that that's a really key difference compared to many other similar guidelines. And of course, the second aspect that we worked a lot with is that stating these principles is relatively easy, but what's hard is of course operationalizing these. So therefore we took 2 further steps. First of all, we defined a set of requirements based on these principles, and secondly, we also developed an assessment list to help companies and organizations ask questions to verify or to convince themselves that they actually have living up to these requirements. And the latest version, the kind of final version of this assessment list was published last summer. So the principles that we defined in the high-level group in this ethical guidelines for trustworthy AI is based on fundamental human rights. And the first one is then respect human autonomy. And this is all about augmenting, complementing, and empowering people rather than replacing them. And it's also very important that we should be allowed to make our own decisions. So this is very important. Second is kind of natural prevention of harm. So we want the systems to be safe and secure, both from a physical and mental perspective. Thirdly, they should be fair, which means that it should be equal and just distribution of both the benefits and the costs. And I mean, it should both be on the individual level and on the kind of group level, the society level. And last but not least, we have also explicability. So this is really about understanding these systems. So it's about being transparent so we can understand who is doing, who's behind these, what are they based on, what can they do, what cannot they do, what's the purpose. Also, I mean, this right to an explanation to be able to explain how the system works and what the outcome is based on. So these are then the principles. So what's really interesting here is that all these principles are, of course, very well respected and very important and nice, but how to actually achieve them in technical AI systems is still, to a very large degree, an open research question. And in order to address these very important aspects, we then have this TAILOR network. So this TAILOR network is one of 4 called ICT-48 networks funded by the European Commission. And the scientific vision of TAILOR is to develop the scientific foundations for trustworthy AI. And we strongly believe that in order to do this, we really need to integrate learning, optimization, and reasoning. So we don't believe that either of these kind of 3 major approaches to AI will be sufficient in isolation, but rather we need to combine them in order to really build these trustworthy AI systems. So the TAILOR network then brings together leading AI research centers from these 3 areas, together with major European companies that then represent important industry sectors. So of course, I mean, even though we have a relatively large consortium with 54 partners, you still cannot include all the relevant and interesting companies there. And we are going to develop a single scientific network that then address these scientific foundations. And something that we really think is really important is this to reduce the fragmentation. So I mean, we've seen that we have all these kind of sub-disciplines within AI. We really think it's important to bring them together. And that we also want to, again, these challenges that we're facing are so difficult that you cannot do it by yourself, but you really need to collaborate with other researchers. So therefore, boosting the collaboration is a very important aspect. And of course, we want to increase the AI research capacity in Europe so that we can both attract and retain talents and develop very useful solutions, of course. So we started in September last year, and we will work for 3 years, and I'm the coordinator, and the total budget is 12 million euros, which may sound like a lot, but considering the scope and breadth and the number of partners, is actually not that much funding in the end. But of course, it's very important and significant funding. So if we look at the consortium, as I said, we have 54 partners from 18 different countries, basically covering most of the European countries, and then also Israel and Switzerland. Actually, when we started, when we wrote the proposal, We also had a call for partners because there were so many people that wanted to join this consortium. So we had a call for partners with more than 130 applications. So unfortunately, we couldn't take everyone in as partners, but then we have also created what we called a network members. So people and organizations that don't get direct funding, but are still part of the network. And we also have what we call a connectivity fund, which is a mechanism that I will say a little bit more about later, about also providing third-party funding for these network members. And I should also mention that CLAIR has been one key factor in putting together this proposal. So we're really benefited from the CLAIR network and the CLAIR infrastructure in setting this up. And of course, we also see that CLAIR could be a mechanism for making this a very long-lived network activity. Yeah, I think I've said this about the scientific vision. So it's basically we want to develop the technical AI solutions in order to be able to deliver on this EU vision of trustworthy human-centric AI. And if we look at the kind of basic research program, there are 5 basic research work packages. 1, 2 are what we call horizontal, so they cover the full spectrum of the, all aspects of the network. That's trustworthy AI, and the second one is paradigms and representations, and really the integration of paradigms and representations. Then we also have 3 vertical work packages on learning and reasoning for acting. So all about making decisions and carrying these decisions out. Social, so again taking this kind of both multi-agent and human aspect into account. And finally, auto AI. So really, how can we kind of lower the threshold for people and organizations who want to take advantage of the latest AI techniques, and in some sense also democratizing the access to these tools. So if we look at this in a little bit more detail, the trustworthy AI part is really related to this requirements that's defined in these ethical guidelines, and the 6 important dimensions: explainability, safety, robustness, fairness, accountability, privacy, and sustainability. So that's the kind of core, and then we have more specific tasks working on explainable AI, for example. One example is how to generate multimodal explanations. Another one is about safety and robustness. A third is about fairness, equity, and justice by design. And the fourth one is about accountability and reproducibility by design. And here I just want to add use an example from my own research. So I've been working a lot with autonomous systems. So in our case, like helicopters, 100-kilo helicopters that you see in the video here. And really one thing that we're really interesting is how can you monitor and make sure that these systems are safe. So in this relatively simple example is about picking up a box, but actually when do you succeed with picking up this box? I mean, in this case, we had a magnet attaching to the box. I mean, the magnet did attach to the box. It started to lift, everything looked fine, and then after a little while it dropped. So what means is that this is very complex spatio-temporal properties or patterns that you need to detect. As we have then been working about how can we express this, so how to combine, in our case, temporal logic and probabilities, and also not only just monitoring the past, but also building models of predicting the likely future, so we can monitor both the actual observed past and the likely future. So we can then integrate all of this into a logical, I mean, in our case, temporal logical framework, and then express very complex and powerful statements, and to actually verify them online in real time as the system is being run. That's one example. So the second horizontal is really about this paradigm and representations. So there are a wide variety of very good and very useful representations. I mean, we have logic, probabilities, neural networks, and so on and so forth. And what we see today is that there's a lot of interest in how can we combine these different representations to get the positive and the power of each, but getting them together. And again, this is both about actually integrating the paradigms themselves, but also to integrate and connect communities working with these different types of paradigms and representations. This work is led by Luc de Rat, and the Trustworthy AI part is led by Fosca Gianotti. And this integration of paradigms is also very much related to this model of how humans think that's been popularized by Daniel Kahneman about this system 1 and system 2, where system 2 is this slow, explicit, deliberative, analytical mind, which is basically what in this kind of more traditional logic-based systems have been trying to emulate. So how do we mechanize that kind of reasoning? And on the other hand, we have the system 1, which is this fast, automatic, unconscious, effortless systems, which often works very well, but sometimes, I mean, fail. So, I mean, I think intuition is a very good example here. When you post with a question, you intuitively often feel what is the right or wrong thing to do, or what is the answer to this particular question. And in many cases, it is correct, but sometimes it's not. And I think perception is another example where, I mean, we don't have any introspection in how our visual system really works. And what we see here is a lot of similarities with this data-driven machine learning types of approaches. So of course, the really interesting thing is how can we combine these just like we humans combine these two different systems. So the kind of things we're interested in this work package is integrating different representations for learning and reasoning, and to do that also for optimization. And then working with these embeddings, knowledge graphs, ontologies, perception, spatial reasoning, vision, and so on. So all these very interesting questions. And here again is from a more personal perspective, that what I really think is important is that we need to move away from this purely correlation-based approaches to more causality-based approaches. And I also think we should leverage both the rich data that's available, but also all the knowledge that we have gained through science throughout the centuries, and how can combine both this kind of data and the knowledge, and to build these causal models and use these causal models to explain what happened in the past, so basically looking forward, but also using these models to predict into the future. So this is kind of things that I'm personally very much interested in. The first vertical is about reasoning and learning for action. So, I mean, here a lot. I mean, for example, we have planning as one example of reasoning in order to determine how to set up a sequence of actions that will lead to the agent achieving a goal. And we also have learning agents, for example, reinforcement learning agents, which tries out different actions, and depending on the reward it gets, it adapts its behavior. So we have these two different approaches, which both have been very successful in different applications. And now what we're really interested in is how can we combine these two together so we get both a reasoning and a learning agent. And this work package is led by Giuseppe Di Giacomo. So he's very much interested in this, combining these different approaches into new approaches. So here we're interested, for example, in how can we have more extended and multifaceted models of the world dynamics? How can we integrate data-based methods and model-based methods? Learning for reasoners. So actually, this is an area where I've been doing some work. So actually, we have so we're working here on how can we use learning to learn heuristics for reasoning, but also how can we use reasoners and planners for learning? So can we combine planning with reinforcement learning, for example? And how do we monitor and make sure that all this is then trustworthy? The second vertical is about reasoning and learning in a social context. So this work is led by Anna Paiva, and here it's all about both modeling and understanding how multi-agent or social systems work. So for example, how can we integrate individual knowledge and knowledge available to and from other agents? How do we design social AI systems? How do we do collaborative decision making? So rather than just the individual decision making by single agents, but to do this collaboratively. And how do we aggregate preferences in a fair manner? And of course, also, I mean, how do we learn in a social context? I mean, most learning is very much on the kind of individual agent perspective, but it's also very important, how do we learn in this social context and from others? And also how to design complex social structures, organizations, and institutions. So the final, the third vertical is all about auto AI. So I said basically about democratizing the access to AI, but it's all about automating this labor-intensive, error-prone aspect of actually building highly efficient and effective AI and machine learning systems, and also to make them more trustworthy and robust. I mean, there's a lot of this talk about this. How do we kind of make them robust and trustworthy by design? And I think by integrating the kind of, for example, take just a simple example, the hyperparameter optimization into the system rather than doing this by hand on the outside. So here there are a number of very interesting topics, and this work is then led by Holger Huus. So for example, how can we actually use this in practice, not only in the kind of lab environment, but for real? And here we're also collaborating with companies. How can we go beyond the standard supervised learning, which is kind of traditional here? How do we build self-monitoring AI systems, so that systems that can actually monitor their own behavior and detect if something is going wrong and then try to fix it? So actually the work that we've been doing there on this combining monitoring and monitoring of the past and monitoring of the expected future can be used to compare whether the predictions that you made actually turned out to be correct. And if your predictions were not correct, then you can use this as input to modify your learning of these prediction models. How do you do this multi-object? I mean, because I mean, when you build an AI system, it's usually not only one aspect that you need to take into consideration, but actually many. So how do we trade, or how do we deal with this multi-objective setting? And how do we do it over the long time perspective, not only just a single application, but to make sure that these systems keep evolving and producing good results also in the future? So that was a quick overview of the kind of scientific content of the TAILOR project. So of course, as I said, we have a number of industry partners. So for example, ABB, Bosch, Philips, Luxembourg Institute of Health, Volkswagen, ZF, and so on and so forth. So, and these, of course, very good companies are very representative of their sectors. So, for example, this automotive or mobility sector, energy sector, industry, health, public sector. So what we want to do is to do what we call theme development workshops, where we take a number of companies and researchers working in that area, and together identify the main or key scientific challenges that we can then work on within the project together with these industry partners. As I mentioned, we're also very much about being open and inclusive. So we have therefore allocated a substantial amount of funding, 1.5 million euros for third-party funding. That is that we will allocate through a open call system. So every 4 months there is there is a continuous call. So what we do is every 4 months we collect all the applications that we have received, and we evaluate and award those that are good enough the funding. So this means that to submit an application, you need to combine one partner or at least one network member, or non-partner, I should say, and that these two then submit a joint application, and each organization get at most 60,000 euros, and the details are on the website. But the two main things that we're looking for is visits. Of course, that's a bit tricky these days, but hopefully that will be open up soon, so that either you can invite a TAILOR partner to, if you're a non-TAILOR partner, or you can visit, if you're a non-TAILOR partner, you can visit a TAILOR partner, and organizing joint workshops. So this is organized by Joachim van Schoren from Eindhoven. Yeah, skip this one. Yeah, to kind of summarize, the purpose of the TAILOR network is really about developing the scientific foundations for trustworthy AI, and to build and to kind of bring these different communities from learning, optimization, and reasoning together, so that we can work on these challenging and very important topics together. I should also say that TAILOR, of course, is part of a larger European ecosystem. So there are four ICT-48 network. So besides TAILOR, we also have Humane AI Net, which is really about the interaction between humans and AI. We have AI for Media, which is covering all aspects related to media, and AIICS, which is this European Laboratories for Intelligent Systems. So the AIICS network, their network, which of course very much focused on the latest machine learning technology and beyond. And then what we also have is the coordinating support action vision. So this is really kind of supposed to coordinate these 4 networks. And then we have a number of other important initiatives, the AI4EU, which is organizing this nice cafe. We have the digital innovation hubs, where there will be a number of AI-related digital innovation hubs coming. We have the kind of existing PPPs on robotics, e-robotics, and big data value association. And of course, now there is ongoing work on forming a new public-private partnership on AI, data, and robotics, which then involves both these 2 previous PPPs, but also EurAI, the European AI Association, CLAIRE, and AIICS working together for this. So a lot of things is happening on the European scale. Since I'm here, I also wanted to take just a few seconds to give a very brief overview of what's going on in Sweden, because Sweden is actually doing quite a lot in this area, and I think we're starting to get a very nice coordinated AI ecosystem. So of course, the kind of foundation is the universities. I've just listed a few of the universities here, and then we have a very large research program called the Wallenberg AI Autonomous System Software Program, which is a basic research program funded by the Knut and Alice Wallenberg Foundation. And I mean, in total, we have a budget of about 550 million euros over 14 years. So it's very substantial, and most of the funding is coming from these private foundations, but there's also significant co-funding from universities and from companies. And this is really about building competence. So one of the goals is to educate 600 PhDs in the area of AI, autonomous system and software. And that's the part that I'm leading. I'm leading the graduate school, where we currently have about 300 PhD students in that. So we're only halfway. And also to recruit internationally. So if you're looking for positions, this is a perfect opportunity. And then we have AI Competence of Sweden. So this is really about professional education related to AI. So a number of universities that received some initial funding from the government to build up activities for people already working both to improve the competitiveness of Sweden, but also to improve the welfare. So it's both about the public and the private sector. Then we have another very nice, I would say, public-private partnership called AI Sweden, previously known as AI Innovation of Sweden. So this is an organization really focused on accelerating the use of AI in Sweden. So we are there. We are having different kind of infrastructure. So there's a data factory. We just launched an edge lab. So you can test edge computing, and there's a lot of both public and private organizations and working together to push AI solutions. And then I have this AI Sustainability Center, also funded by the Swedish Innovation Agency, about helping organizations to use AI in a long-term sustainable manner, both from kind of ethical but also a sustainability perspective. So there is a lot of very nice initiatives going on. And of course, we also have a Swedish AI Society and WASP HS, which is WASP Humanities and Society, which is a sister program to WASP, focusing on studying different aspects of AI autonomous systems from a humanistic and social scientific perspective. And this work is then led by Virginia Dignam. So that's a really also fascinating research program. So to conclude, I've been given an overview of what AI is, and I do think it's about understanding intelligence and developing systems that exhibit intelligent behavior. And that I haven't talked about this, but as you can guess, AI will affect all aspects of society, and therefore trust is absolutely essential. I think we are kind of at a tipping point, and if companies and organizations don't gain or regain or continue to maintain the trust of us, the users and citizens, there will be major issues. And to be trustworthy, these systems should be legal, ethical, and robust. And this entails a number of very important scientific research challenges related, for example, explainability, safety, fairness, accountability, and so on. And that is very interdisciplinary in their nature. And then this TAILOR ICT-48 network is really committed to develop the scientific foundations for trustworthy AI. And we strongly believe that we need to integrate model-free, data-driven learning approaches with more model-based, knowledge-driven reasoning approaches, and also optimization. Because in the end, what we want is human-centered, trustworthy systems. So it's really about AI and humans together. Thank you very much.
Thank you very much, Fredrik. Thank you very much. Very good insight into TAILOR. And now we have the Q&A session, and I'm the first, and then I will read the other questions. And my first question is, because I get this always asked, can you just give me an easy example? What is trustworthy AI today? I mean, is there an example out there existing which you would say you trust?
I mean, I do think that's a very good question. I mean, I think there are a lot of systems we trust. I mean, take a search, and if when I use a search engine, I mean, I expect that to mostly give the right results, but of course I also have to be wary that it may sometimes give strange results. But I really think that what you do is probably build this up over time, and that, I mean, as long as you're using it and you see that, oh yeah, it gives reasonable results, therefore I continue to use it, and so on. So I think that's one example. Okay,
it's like, here comes now the question. I think it's similar, and I like it. It asked the other way around. Felix Ingrand asked, anything considered to prevent some rock companies to develop non-trustworthy AI? Like, for example, Cambridge Analytica. Do you do something to prevent it?
Okay, sorry. I mean, of course, that's also included. I would say that, I mean, what you want to do, I mean, now, I mean, these ethical guidelines is, of course, some form of soft law, so to speak, that if a company, nice, you have a printed copy, nice. That you want, I mean, by following these, you want to reduce the likelihood of companies actually doing bad applications. So it's, in some sense, it's supporting them, but of course it's voluntary. But I do think that here consumer power is going to be very important. If we as consumers don't accept applications that haven't followed these guidelines, then that will have a natural effect that if you cannot show that you have at least tried to live up to these guidelines, then you will have a much harder time selling your products. And I mean, I do think we see exactly the same thing when it comes to, for example, sustainability or environmental aspects. And actually, there is a lot of parallels with the work that the European Union was doing on limiting emissions, I think in the 90s, or maybe it was even earlier, by putting this strict requirements on the emissions within the EU. They were pushing innovation in Europe. So when the rest of the world were following on and also introducing similar legislation, European companies had an advantage because we already been used to living up to these much higher expectations. So I think I would say that those are two things. I mean, we as users and consumers should have high expectations, high requirements, and if they don't behave, we should stop using them.
Yeah, thank you. I'm same here, and this it basically goes in the same direction from Bjarke Nielsen. Basically, we all ask the same thing. Fredrik, it's a question to you. Do you think some of the various guidelines will end up having to be expressed in a common industry test or even in a certification scheme? Historically, compliance requirements are expressed best in actual testable terms. If so, who would initiate such a level of compliance scheme?
I would say that there already is a lot of standardization work ongoing. I know ESO is having a group on standardizing aspects of AI. So in general, I think standardization is a good thing, but it's hard to standardize before things are kind of mature enough or well understood enough to make the right standard. I mean, if you take like 5G or something, there in some sense you're inventing it through the standard. So the standard defines what it is. But here I think we probably need to, probably have both kind of, when something is more mature, then you can standardize it. And then you have to sort out a number of issues, of course, to make it testable, as you say. So I do think there are a lot of things that you probably already today could standardize, like more. I mean, I think a lot of this automated decision support system, because basically then you have a decision, so you have something you should decide upon, you have some kind of inputs, these are the factors you base your decision on, you have some form of rules or regulations that this decision has to be based on, and then you have a verdict. And I think certain kind of key aspects can probably be both standardized, and then you can do the certification. I know there's a lot of work in Germany related to standardization, and I believe that it came out a report in end of November or something like that, looking at exactly how to work towards standardization related to AI.
Yes, so there's a lot of work out. The last question, our time is nearly off, from Natalie Saint-Pierre. She is from Canada, and therefore the last question: do you have network collaborators in Canada?
So I mean, yes, we do have collaborations with Canada and other parts of the world. When it comes to this particular, I mean, the funding aspect, we cannot fund work outside Europe. So there are, of course, limitation what we can do from a kind of budgetary perspective, but we are very much interested in collaborating. We will, I mean, the TAILOR project also has an international advisory board with people from many different countries, also providing an international aspect. And of course, all of us, we have a lot of international collaborations and so on. So yes, we are very much open to international collaboration. unfortunately, we cannot fund any such through just this EU mechanism.
Yes. Okay, so now it is 4 o'clock, and I thank you very much that you have been here with us. You, Fredrik, thank you, because we have now an insight to TAILOR, and thank you for the more than 118 participants. That's a lot of people, and they cannot all ask their questions. So if you have something burning, you might send it to me, and I can forward it to Fredrik. As well as I will get the presentation afterwards, and who needs it, wants it, please send me an email, remind me, and I send it to you. So this is the way, and soon the recording might be online if Fredrik allows it. I will first send you the recording, and if you say, okay, green light, then we put it on YouTube and you get the link. So, and thank you again. Please come back next week. It's always Wednesday at 3 p.m. Next week, we have also a great speaker that will be from AI for Media partner. So we get the insight from Hannes Fassold, and I will send you soon an invitation. You will find the information automatically because you get the invitation. Okay, see you soon, and thank you, Fredrik, until one day in real world cafes.
Okay, bye-bye. Thank you very much.